everyone, and welcome to lesson 27.1, part 1. Today we're going to split this lesson into two parts, but we're going to start on page 391. We're going to continue talking about circles, but this time specifically the equation of a circle. On page 391, we see here the equation of this circle, and notice some of the points given on the circle: 1, square root 3, and 0, negative 2. And we want to show that those points do in fact lie on the equation of this circle. Now remember, anytime you square a square root, or square root a square, it equals that value underneath there. So just keep that in mind as we're plugging these in. So to prove that these do in fact lie on our circle, what we need to do is we are going to plug in for x and y these values to test. So we're going to plug them into the equation that's given. So 1 squared is going to get plugged in for x squared plus the square root of 3 squared. Square root of 3 gets plugged in for y, and we're double checking, does this in fact equal 4? Right, that's the question of the day. Well, 1 squared is 1. Square root of 3 squared, as we talked about over here, cancels out as just 3. 1 plus 3 does in fact equal 4. Also going to test this out with our second point here. Again, plugging in x comma y, 0 squared for x, negative 2 squared for y. Reminder that 0 squared is still 0, and anytime you square a negative number, it's going to be a positive. So make sure you use parentheses when you type this in your calculator, because order of operations, it's going to be 4. If you forget to use parentheses, you're going to, what your calculator is going to do is it's going to do 2 squared times negative 1. That's a no-go, okay? So make sure whenever you're squaring a negative number in your calculator, you use the parentheses, or just know it's always going to be a positive, okay? So keep that in mind. Now, back to our notes. We know that's 4. 0 plus 4 was 4, and again, that checks out. Okay? Now, try the next two on your own. So again, what you should see is negative 5 squared plus the square root of 11 squared is 25, again, positive, plus 11. 25 plus 11 is 36, so that one worked out. Same thing with 6 and 0. 6 squared plus 0 squared is 36 plus 0, which again satisfied our equation that it equaled 36 for this next one. So those points did lie on the circle. Now, when we are looking for a point on a circle, on the distance from the center to the point on the circle, we know that's the length of the radius, right? And if we didn't know that, what we could do is we could use the distance formula to find that. Now, we talked about the distance formula only briefly before, but reminder, the distance formula is x minus 0 quantity squared plus y minus 0 quantity squared, and that's going to equal 5 for this equation, because notice our one point is 0, 0, and we're looking for this other point, x and y. So we're plugging in x minus 0, y minus 0, quantity squared. Well, if we squared both sides of our equation, right, which is legal because we're doing it to the left, you got to do it to the right, the square root and the square is going to cancel out, and we're just left with x minus 0 quantity squared plus y minus 0 quantity squared equals 5 squared, which is 25, okay? Now, simplify this a little bit more. X minus 0 is just x. Y minus 0 is just y. So we can call those x squared and y squared equals 25. This is the equation of the circle up above, okay? But that's a little bit complicated, right, to constantly always be plugging into the distance formula and trying to find that information. So instead, we kind of have a common formula. If we just call any center h comma k, and we do this same process as we did up above, we would say that x minus h, x and h are both the x values, y and k, we're still square them, y minus k squared equals the radius. If, again, we square both sides, this cancels out, and we're left with r squared. So we have the overall equation of a circle. Now, I like to call this x hikers because it's x minus h, y minus k, for the radius, all of it squared, right? That's what the x hikers, everything squared, okay? This is incredibly important to know the equation of a circle. This is the standard form of the equation of a circle. Highlight it, write it down, star it, whatever you got to do. This is what you're going to want to have on your paper constantly over the next couple of lessons. Okay. So what we want to be able to do with this is now be able to, when we're given the center and a radius, start finding the equations of these circles. Now, again, the center of your circle is always a point called h comma k. So if we look here at for number 4a, if our center is at 0, 0, that's our h and our k. So we're going to plug into x hikers, x minus h quantity squared, y minus k quantity squared equals our radius squared. Well, we're going to plug in all of these values, right? We have h and k are both 0 and 0. We have the radius is 7. And you're always going to want to simplify. Now remember, x minus 0 we said is just x squared. Y minus 0 is just y squared. 7 squared is 49. Now we're also going to do that if our center is 0, comma 2. Okay, again, so we're going to have letter B here. And you're going to want to plug in, again, write down that formula, x minus h squared plus y minus k squared, do not break the squares, equals r squared, x hikers. And then this time our h and our k are 0 and 2. So we're going to plug those in for h and k. The center values, radius is 10. X minus 0 is just x. Y minus 2, we're just going to leave as y minus 2. Again, don't forget to square it. 10 squared is 100. Last but not least, we have h and k this time to be 9 and negative 4, and our radius is square root of 15. So for part C, plug into the formula. X minus h quantity squared plus y minus k quantity squared equals your radius squared. Plug in h and k, and then your radius is the square root of 15. So as we simplify, this time x minus 9 doesn't simplify, so we'll just leave it as x minus 9 squared. And then minus negative 4. Remember, whenever you have minus a negative, that turns into a plus sign squared. And then reminder, the square root squared cancel out. Oops. And we're just left with 15. Since we squared the square root of 15, right? Watch this. Square root of 15 squared, again, was just 15. That's why we left it there. Okay. Now, notice the relationship, for instance, with part C. When we plugged it in, this was a positive 9 and a negative 4. When we plugged it in, it almost looks like the signs flip-flopped, right? It looks like now negative 9 and positive 4. Because of it always being minus, it's almost like your sign flip-flops from the equation to what the actual center is. And so that's what's going on here. If we look at part 5, if we are trying to figure out the center and the radius, we have h is 2, and then k is, we have the plus 1 there. But remember, it's like saying x minus h and then y minus negative 1, right? So we have to be careful because for number 5a, our center is actually at 2, comma, negative 1. It's almost like an opposite game here, okay? And then the radius is not 9. The radius is the square root of 9 because remember, it's r squared in the equation. So r squared is 9, so r is just 3. For part B, again, be careful. The center is not at positive 3. It's minus negative 3, made it become the positive. So it's negative 3. And then remember, anytime it simplifies to just be y squared, That just means that it's at the point 0, right? Kind of going back to example 4a, the zeros just became x squared and y squared. And again, your radius is not at 10. 10 is your radius squared. So you're going to have to square root 10 to get the value of your radius. So we'll just leave that as the square root of 10. Okay, now to finish out for today, we also want to be able to find the value of the equation of a circle given a point on the circle. So first of all, we know that the circle has a center at h comma k. So x minus 2 quantity squared plus y minus -3 becomes plus 3. And that again is going to equal our r squared. But the problem is we don't know the r squared right now. So what they want us to do is we're going to substitute in for x and y. Since we know this is a point on the circle, we're going to substitute this in for x and y. So it's going to be the exact same thing we have written here. So I'm going to clone this. But plugging in for x and y, we're going to plug in 5 and 1. Because like we talked about at the beginning of the lesson, if those points lie on the circle, it's going to equal, the left-hand side is going to equal the right-hand side. So what we're going to do then is we're going to simplify this. 5 minus 2 is 3. 3 squared is 9. And then 1 plus 3 is 4. 4 squared is 16. So 9 plus 16 is 25. That's what our r squared value is going to equal. So our final answer, the equation of our circle, we don't want x and y plugged in because we want to just have the general equation. But now we have what r squared equals. It's 25. Okay. And a reminder, the radius is not 20 or 25. The radius squared is 25. So our radius in this question, in case they asked us, would have been 5, the square root of r squared. Okay, and our final piece for today is we want to be able to check then once we have the equation of a circle, our points, certain points on the equation of the circle. So once we found this equation of the circle, they want us to check is 2 square root 6 on that. And when we substituted it in, we would check, okay, yes or no. Now, the problem with number 7 is when we substitute this in, and we're checking through his work, he's plugging in x and y. Okay, that's great. But remember, 2 squared is 4. Square root of 6 squared is not 12. This should have been a 6. So 4 plus 6 is only 10. 10 doesn't equal 16. So why it's going to be wrong on this one, because 10 does not equal 16. This point can't be on the circle. Okay, so this is going to conclude day 1 with the equations of a circle. Again, super, super important you have this written down, and we will work more with this in class and in tomorrow's lesson. Thanks, everyone.